and you're on.
Well, thank you. Thanks everyone for being here this morning. My name's Steve Lee. I'm just recently retired from the Denver Museum of Nature and Science. I was one of the space scientists there. I'm currently still part-time at the Space Science Institute up in Boulder, and my entire career has been devoted to studying the planet Mars. And so what I wanted to do today is give you a quick update on Mars exploration. We'll do a little bit of background on what we've found out so far, and then I'll give you a recap of some of the recent missions. So let me go ahead and get started here. I think I did that wrong. Just a second. Oh, I guess I am sharing. Okay. And there we go. So what we're seeing here is a view of the planet Mars from the Mars Reconnaissance Orbiter. One of the cameras that I've spent the last 15 years working on. It's sort of a weather satellite view of the planet. And this is a view back from about 2008 of Mars from that mission. But what I'll be talking about today really is a whole lineage of Mars missions. And this actually is a somewhat out-of-date slide, but it shows up until 2011, all of the missions that had been launched to Mars. And we started back in 1960 when the Russians launched their first mission, or the Soviet Union rather. And the first successful mission was actually back in 1964 with the Mariner 4 mission, which was the first successful flyby of Mars. That gets us through orbiters, a number of landers, and rovers on the surface. And so all told, up until right now, we have launched 67 separate missions to Mars. And the sobering statistic here is out of those 67, 25 have succeeded. Right now, there's 3 spacecraft on their way to Mars, so hopefully we'll be updating that to 28 in just a few months. So just quickly, the background setting the stage here. Mars is about half the diameter of the Earth. And so it's these are images to scale, and a little bit about the conditions on Mars. First of all, the Martian day is about 37 minutes longer than the Earth. And so as our discussion proceeds, I'll probably slip and say it's Sol something or other, a number. And with the landed missions, a Sol is a solar day or a Mars day. Rather than constantly saying Mars day, what we mean is a Sol is 24 hours, 37 minutes. And on any of these landed missions, Sol 0 is the day that that mission lands, and then you increment by 1 every day that the mission is operating on the surface. Okay, a year on Mars, roughly twice Earth a year, 687 days. The gravity on Mars is about 1/3 of Earth gravity. And then we get into the really big difference, and that's the atmosphere of Mars. It's almost entirely carbon dioxide, a little bit of nitrogen. Oxygen is just a trace gas in the atmosphere. And then the big deal is the surface pressure on Mars, what we've standardized as, if you will, Martian sea level, is about 0.6% of Earth sea level pressure. And that amounts to, you know, if you were on the Earth in a, say, a military research plane at about 80,000 feet altitude, that's the pressure you see on the surface of Mars. And there's a couple of, well, I'm sorry, before we get there, because the atmosphere is so thin, it doesn't really hold very much heat. And so you have a huge temperature swing from day to night. On the surface, daytime, middle of summer, high noon, you might see roughly room temperature, 20 degrees Celsius. Everywhere on the planet at night, it drops more than 100 degrees C. And in the winter time, Mars is tilted on its axis about 25-ish degrees like Earth. So in the winter time, the polar region is in darkness. It actually gets cold enough that you start freezing carbon dioxide out of the atmosphere. So you get dry ice, snow, and ice sitting on the surface. And then as springtime proceeds on that hemisphere, that dry ice sublimates, evaporates back into the atmosphere, and then it goes to the other pole and condenses out. So there's a carbon dioxide cycle, if you will, on Mars. But one of the big implications of both the low pressure and the low atmospheric temperature is you cannot have liquid water stable on the surface of Mars. If you had a water bottle, pour it out on the surface, it would do one of two things. First of all, it's likely to freeze. Second of all, it's going to evaporate into the atmosphere. So you can't have puddles of water sitting on the surface, which going on to some of our Mars observations over the years, that leads us to some conundrums here, because from orbit, we see lots of evidence that there was running liquid water on the surface of Mars. This is a dry riverbed. This is a canyon carved by probably a catastrophic flood where you just had a huge rush of water draining through this area and carving a canyon in the surface. So what that tells us is that the environment of Mars, the atmospheric pressure, must have been much different in the past. It would have needed to be probably 300 to 400 millibars, say 30% Earth pressure, and it would have needed to be much warmer to sustain liquid on the surface. And now we can't do that, and so that says that there's been very, very major changes over the history of the planet. One of the other things we see is that even though the atmosphere is very thin, it is effective at moving material on the surface. This is an area called the Shark Tooth Dunes. Each of these black mounds is a single sand dune, roughly 100 meters tall. So these are equivalent, a single one of these dunes is equivalent in scale to the Great Sand Dunes in southwestern Colorado. So we see a lot of that. This is a really pretty picture, but it also tells us something about the atmosphere. All of these dark squiggles are really striking, but what we believe these are caused by are dust devils sweeping across the surface. And the basic model for Mars is most of the surface is covered in dark sand or dark material. And then you get this very bright, very fine dust settling onto the surface. And that's what gives Mars its generally reddish or caramel color. When you have a dust devil sweep across the surface, like here or here, it can actually sweep the dust off of the dark substrate. And that leaves these dark trails behind. And we've actually managed to capture some of these dust devils from the orbital cameras. This is the bright stuff here is the dust cloud. The dark thing here, it's a little misleading since I told you about the dark streaks, but this is actually the shadow of the dust column being cast on the surface. We have seen lots of dust devils from the Mars rovers. Spirit and Opportunity captured hundreds of these things sweeping past their area. We've also seen them with the Curiosity rover. And so dust devils are very, very active on the surface of Mars. But in addition to that, we see massive dust storms almost continuously. Somewhere on the planet, we have these little dust storms. This is only the size of the state of Colorado. It's called a regional storm. And any given day, you're likely to have one or at least one, more often than not a couple of these going off somewhere on the planet. And so that is what contributes to suspending dust into the atmosphere and raining the dust out more or less planet-wide. Just to put this in context, this is a fairly small dust storm encroaching on downtown Phoenix a number of years ago. So we certainly see things like this on the Earth. It's just that they're much larger scale on Mars. And this is a view from Mars orbit. This is the North Polar Ice Cap. And here we've got one dust storm. Here's another dust storm. Here's a third dust storm. And if you can see it off on the horizon there, there's a fourth one. And we'll look here, put this to scale on the Earth. Here's North America, or the continental US, and that dust storm would stretch from the Canadian border all the way down into Mexico. And so at the extreme, occasionally, every several years, we get a dust storm that just explodes and it turns into a planet encircling dust event, a PD, AKA global dust storm. And this is a view from 2001. And this is a view of the surface of Mars. This image on the right was constructed from data about 2 weeks after the first one. And you can still see this bright area down here. So we're looking at the same hemisphere of Mars. And in that time period, the entire atmosphere has been choked with dust. And this is just a time lapse of one of these storms happening. You'll see dust kicking up here in this big impact crater. And each frame is 1 day apart. And so over the course, once it starts of 1 to 2 weeks, you're choking the entire planet. And there's lots of implications for that. One is if you're a solar powered spacecraft, when these dust clouds are choking the atmosphere, you're getting less than 1% of the normal solar energy reaching the surface of Mars. So if you're relying on solar power, you're in trouble. And that has been a problem, and I'll talk about that as we get to it. So let's quickly start with the Mars exploration rovers, Spirit and Opportunity. So these arrived at Mars in January of 2004. And they were designed to be robot geologists, and they were each sent to an area of Mars that there was evidence based on the orbital observations that liquid water may have existed on the surface in these 2 spots. And the goal of these missions was to look for evidence that indeed water had been present on the surface. And so here's a map of Mars. Spirit landed in an area called Gusev Crater. Opportunity was in a plains area called Meridiani. And so here's Gusev Crater from orbit. It's about 100-kilometer diameter crater, but what you see is there's a dry riverbed flowing out of the crater. And that would indicate that if indeed liquid water was there, that this would have been a lake filling this crater. And so cutting to the chase, Spirit made observations for about 6 or 7 years. And one of the things that it discovered in just happenstance, driving along, it kicked up some of the regolith, the soil on Mars, and uncovered this really bright material. And when they analyze that material, it's almost pure silica. It's basically tiny, tiny quartz grains. And on Earth, we see this in areas like in Yellowstone Park, where you have hot springs and mud pots percolating up with hot water flowing through to the surface. And the way this works is that at depth, the water can dissolve the silica, the quartz, and then it gets to the surface, the hot water evaporates, and it leaves behind the contents of whatever was dissolved in the water. And you can make these silica deposits. They're called Silica Sinters. And we understand those on the Earth. That's what we think we discovered on Mars with Spirit, that it was driving through an area where there were hot springs. And so it's a geothermal pools of water. And then this is just showing you the dust settling on the rover. This is a view. The rover has a robot arm with a camera on the end of it, and they are able to take effectively a top-down view of the spacecraft. And so at launch, these solar panels were all nice and black, very shiny, pristine. This is what the spacecraft looked like after about 2 years on the surface. So a lot of dust had settled out, but lo and behold, a dust devil swept through and went right over the top of the rover and essentially vacuumed most of this dust away. And that was a big surprise. The original mission design was that these rovers would only last about 90 days because of the dust collecting on the solar panels. And in fact, time after time, when the dust coating got critical, the wind swept it away and sort of reset the clock. So Spirit lasted, I think it was about 7 years or so, and Opportunity was at about, let me think, it died about 3 years ago, so it was about 13 years. So,
Dr. Steve?
Yes.
We have a question for you.
Okay.
How do you tell the difference between a lava reel and a fluvial channel?
It's all the people that really understand this. You see that the shape of the channel, the way it curves and meanders, is related to the viscosity of the material. And lava tubes, lava rills have a very characteristic shape, a very characteristic sort of dams and edges along the periphery of the channel. And things that are caused by fluids that are much less viscous, a la liquid water, have very characteristic features as well. So the people that really study this sort of thing, they're very convinced that this is caused by liquid water.
Terrific, thank you.
Okay. So Spirit actually lasted, instead of 90 days, it lasted 2,200 days. It drove about almost 8 kilometers. They were calling it a successful mission if it drove a couple hundred meters. And they were hoping for about 1,000 images back. It actually returned about 128,000. So let's move on to Opportunity on the other side of the planet. This is a view of Opportunity's trek over those 13 or so years. And it landed up here. It spent a lot of time driving down inside a number of craters, and then it ended at this 20-kilometer diameter crater, sort of following along the rim of the crater when it finally expired in 2017. So what drove us to go to this location on Mars was from orbit with spectrometers, we detected the mineral hematite, which is an iron sulfate mineral. And on Earth, we know there's basically 2 ways to make hematite. One, it's a volcanic process, and 2, it's a hydrothermal process where you have iron and sulfur dissolved in water. You get to the surface, the water evaporates, and you leave hematite behind. And so the goal of Opportunity was to see if they could find the hematite and see if they could determine if it was volcanic in origin or water-based material. And so one of the cool things when they first landed is the surface in this area was just littered with these little sort of gunmetal gray spheres. These are about the size of a BB, or just a millimeter or a couple millimeters across, and they were everywhere. And they finally found an ideal location. This was called the Berry Bowl. They nicknamed these things, probably unfortunately, blueberries, just because they looked like little blueberries sitting on the surface. But here was a collection of these spheres, and off to the side was an area where you really didn't have any. And so they were able to use the instruments on the robot arm to determine the chemistry of this spot without any blueberries, and then come over here and look at the blueberries on top of the same rock. And lo and behold, they discovered these blueberries were made of hematite. And so that was exciting. Yes, they found hematite. And then when they had a little rock grinding tool, and when they ground into some of the rocks, they found these little spherical particles embedded in the rocks. And again, to the geologists that study this sort of thing, this was a smoking gun. These are what are called concretions, and we know how they form on the Earth. It's where you have an existing bedrock, and you get hot water percolating through the rock, and whatever the materials that are dissolved in the water end up precipitating in little voids in the rock, and sort of like growing a pearl, and you can make these hematite nodules. They're called concretions. And so we found these in abundance on Mars, and so that really showed that the hematite spheres were due to water. This is a view of an outcrop, and when they got close to that outcrop and looked at it with their microscope camera, here's these little spherical particles poking out of the rock. And you can look at these patterns in the rock, and those are ripples. So these rocks were laid down probably on the edge of a lake bed, and the hematite was precipitating out of the water in the lake. This is an example on Earth of what we think this environment might have been like. This is in Bolivia, a little volcanic island, and this very, very acidic water. And then on the shore of this little lake, you get all this white stuff, and that's where the water is evaporating, and you get these minerals precipitating on the lakeshore. And so that's an analog to the environment that we think existed on Mars in this location in the past. And so Opportunity drove and drove and drove for years and years. And it sampled lots of these areas. But in 2016, there was another one of these global dust storms. So this shows the planet in May of that year. This is the planet in July. This dust storm kicked up, and it ended up taking many, many months to clear. And this is just showing the power output of the solar panels on Opportunity. It's going along sort of at its normal level. Here's where that dust storm kicked up, and instead of being something like 600 watt hours coming off of the solar panels, they dropped down to a small fraction of that. And from Opportunity itself, these are observations looking at the sun in the sky. And here's the dust storm kicking in. You're blocking sunlight until you get to something like this. This was actually the last image returned from Opportunity, and it's essentially totally black. And it took so long for the dust cloud to clear that they were not able to wake the rover up once the dust storm had abated. And so that was the end of Opportunity's mission. And so this is the statistics on Opportunity. It lasted 5,346 Mars days. It was designed for 90. It drove over 45 kilometers, and it returned over about a quarter million images over the course of its mission. Okay, so I'm gonna have to speed up here. Another successful rover is the Curiosity mission, which landed in 2012. And it's a nuclear powered rover. It's still going along very happily. And Curiosity was designed to be a robot geochemist. So it had much more sophisticated instruments on board. It landed in the middle of this area called Gale Crater. It's about a 160 kilometer diameter crater. And what's exciting about Gale is in the middle of it, there's this mound of what appears to be sedimentary rock that it's about 5 kilometers tall, so about 18,000 feet roughly. And so what they did is targeted this area in the crater. They landed very near the center of this ellipse, and they landed close enough that they could actually drive to the base of that mountain. And so here's the mountain after they landed, just, you know, the promised land off in the distance. This is a little closer view. And this is the type of thing that gives geologists, you know, heart flutters. You see layer upon layer upon layer of rock. And the idea is, as you approach this mountain, the lower you are, the older you are. The rocks, the old rocks are on the bottom. As you proceed up in this column, the rocks get younger and younger. And so we know on the Earth, this is the Grand Canyon of the Colorado, you know, it's like turning pages in a history book, starting at the oldest, moving up to younger and younger. And so by being able to analyze these different layers, you get a history of the environment on Mars when those layers were laid down. And that's the goal of the Curiosity mission. And so this is an overhead view from orbit. Here's where the spacecraft landed. That mountain, Mount Sharp, is down off to the lower right. And so all this dark stuff, these are actually fairly thick sand dunes. And so to get to the mountain, they had to skirt along these sand dunes until they found an opening in the dunes that they could cross. And right now they're right near the foothills, if you will, of those mountains, of that mountain. And so one of the exciting things very early on is they found this, broken up piece of bedrock. And when they looked close, first of all, the rock itself is a conglomerate. It's got lots of little rounded pebbles glued together in the rock. And then where the rock is eroded, you're left with gravel. And the individual particles of gravel are rounded. They're not sharp, jagged pieces of rock. And if we look on the Earth, here's a dry riverbed or a dry creek bed in Death Valley. And this is a well understood thing where periodically you get a gush of water, perhaps from a rainstorm. Certainly that'd be the case in Death Valley. And the water gushes across this surface. The little pebbles that are exposed get tumbled against each other. It's over time, it wears off the sharp corners of those pebbles. And so that implies that not only did you have water running through this area, but it was an extended period of water running through the area. It didn't all happen at once necessarily, but you'd get episodic flow of water. And so here's Mars on the left, Death Valley on the right, and you can see, other than the coloration of the rocks, this is a really good indication that the same processes were active. And so Curiosity has this sort of lazy Susan on the end of its robot arm. It's got microscopes, it's got a core drill, it's got wire brushes that allow you to brush off the surface, and then instruments that tell you about the composition of the surface. And so this is just an example of the robot arm extending and examining a rock. Here's a close-up view with the microscope camera of one of these holes that were drilled in the rock. And I misspoke when I said it's a core drill. What it is a percussion drill. It's the type of drill that you would use to drill through a concrete block in construction here. So it's a hammer. It pounds up and down at the same time that it's rotating, and it's able to pulverize the surface and get down several centimeters, something like 10 centimeters deep into the surface. And then once they've got this pile of powder from the rock, they have a little tiny sample scoop. This is about just a couple of tablespoons, but it's able to pick up that material. And then there's funnels in the top of the rover, and you can dump this sample into the instruments and determine the mineralogy, the elemental abundance, you know, what elements the rocks are made from. And they've got an X-ray device that allows you to determine the crystalline structure of the rocks as well. And so they've been going to town over the 8 years or so they've been on the surface. This is just a sort of a family portrait of all of the drill holes that they've accomplished. This was the very first one back early in the mission. This was, you won't be able to read this, but this was 182 days after landing. And this last one is just in the last couple months. It's 2,754 days after landing. And so one of the things you can see is just the variations in the color of the powder. And that, of course, is related to the composition of the rocks that you're drilling into. And so here I just wanted to give a sort of a travel log, some of the really cool sights that Curiosity has seen over its trek. So these are just some mesas and very, very finely layered rock. This is sandstone. And this is the type of thing you'd expect to see in Zion Park or New Mexico or Arizona. So we understand the processes that led to this type of rock. And here you can see some of these ripple patterns again in the sandstone, indicating that yes, this crater was filled with water at some point in the past. One of the things they've been a little surprised at is how much the wheels on Curiosity are wearing. These wheels are carved out of a solid block of aluminum, and they were intended to be as thin as they could make them. But it turns out over the course of its driving, if it drives over a particularly sharp rock, the rover itself weighs almost a ton on the Earth, but that's apparently enough force on these wheels that the rocks can punch holes or tears in the wheels. And so once they discovered this, they started being very careful as they're driving. So every step of the way, they survey with the onboard cameras the road in front of them and try to take the path that exposes them to the least number of these sharp, pointy rocks. And so they're haven't seen a whole lot of degradation since they've adopted that method of driving, but this is still a concern. So it is one of these alarm bells that go off that they have to sort of relearn how to use the rover once they discovered that. And this is just an example of the view from Curiosity when that big dust storm happened, the one that killed Opportunity. And so this is looking at the far rim of the crater from where Curiosity is sitting, and this is what it looked like during that dust storm. And so lots of dust choking the surface, or choking the atmosphere, but Curiosity didn't have to worry because it uses a radioisotope generator. It doesn't rely on solar power. So this is the recap of the entire mission to where they are right now. And so I already showed you this, and what they've been doing recently is driving closer and closer to the foothills. The foothills start down in this area. They've seen some really spectacular sand dunes. These are the dunes that they had to skirt around. And this was a view from fairly early in the mission, and this arrow points to where they are right now, sort of approaching the foothills of Mount Sharp. This is just a cool observation of a mudstone that they drove over. It's got little, this is the type of thing where if you have a big puddle that has soil in it or mud wet by the puddle, and then it dries up, you get these little cracks in the surface, and that's very diagnostic of a mudstone. And then these white inclusions here, these white stripes, when they've measured these, that's gypsum. So it's essentially dissolved drywall that percolates up through the cracks in this mudstone and then precipitates the gypsum into those cracks. So again, lots of evidence for standing and running water in this area. And again, just a nice sandstone. You see these ripply marks, especially down in this area, saying that this was probably on a lake shore back when it was formed. And so here's a recent view. So the mountain is here, the foothills thereafter is there. Their next target over the coming year is to drive to this outcrop. This is a sulfur-bearing mineralogical area based on observations from orbit. And so that will be a very different composition to the rocks that they're excited about doing before they drive off into the foothills. And so we're actually at day 20, 29, 21 is today for Curiosity. And this was one of the last images returned. This was taken yesterday, and here is the robot arm positioning its instruments to take another drill sample into that rock. So this is the recap on Curiosity. It's day 2921. It's driven about 23 kilometers and returned over 700,000 separate images. So this is an ongoing mission and very, very successful. So very quickly, in my last 5 or 6 minutes, I want to tell you what's happening right now. There's 3 new missions on the way to Mars. And these all launched back in July, just a few months ago. And the first one, this is a little surprising, but the United Arab Emirates partnered with the University of Colorado and the Lab for Atmospheric and Space Physics up in Boulder built this spacecraft for the UAE folks. It's called the HOPE mission. And it's designed to go into orbit around Mars and do observations of the atmosphere. So complementary observations to all of the other ones that have been made from our past missions. So here's the spacecraft getting ready to be tucked up into its rocket. The UAE bought its ride to Mars on a Japanese launch vehicle. So this was at the Japanese launch complex in early July, and here's the launch, the 19th of July, and launch was successful. The spacecraft is safely on its way to Mars, and they're busily checking out all the systems. It will arrive at Mars in mid-February of 2021, so just a few months to go, and then commence its mission. So this is the first interplanetary mission launched by anyone in the Arab world, and the UAE is using this as a means to inspire its young people to follow or pursue careers in science, technology, engineering, and math. And so they've basically bootstrapped themselves along to make a space program and have their people operating it and designing the hardware, doing the science, and really advancing the capabilities of their country. So a second mission has been launched by the Chinese Space Agency. This is called Tianwen-1, which translates to Heavenly Questions. And this is actually a very, very complex mission. There's a couple of technicians here. This is an orbiter and a lander. So this harkens back to something like the Viking missions that NASA launched in the mid-1970s. And so this is designed to first enter orbit at Mars, and then once they survey their potential landing sites, they'll drop off the landing capsule, which will descend to the surface. And so their mission is, it comes down under rocket power. And once it's on the surface, it unfolds a ramp, and it's got a small rover. It's the size of a large microwave or toaster oven type thing that will descend to the surface and then drive around for its roving mission. It's got a number of very sophisticated instruments on board. It's got a ground penetrating radar, so they'll be able to look at layering under the surface that they're driving on. It's got a number of cameras. It's got some chemistry experiments to analyze the composition of the rocks, and atmospheric experiments. So it's a very capable little spacecraft. And this will be the first time that the Chinese have sent anything beyond the Earth's moon. They have had several successful landers on the moon, including one that's still active. It landed on the far side of the moon. They have a communication satellite between the moon and the sun that is able to relay the signals from the spacecraft. And it's been successfully driving around for over a year. And so that gives us some hope that this Mars mission will also succeed. This is just, here's the spacecraft and some of the ground crew prior to launch. This was their launch vehicle. And on the 23rd of July, the Tianwen-1 successfully launched to Mars. And it also is expected to arrive in late February of 2021. They expect it will stay, or the orbital reconnaissance of its landing site will take a couple of months. And so there's no definite schedule for the landing, but it will be sometime after February. And they had a little, this was just sort of a cool feature where they were able to eject a wide-angle video camera from the spacecraft, and this was returned about a month ago. So it's a view of the spacecraft cruising to Mars. So here's the solar panels, there's an antenna, that's the landing capsule, and then the orbital capsule. So finally, let's end with NASA's entry into this, this opportunity to launch to Mars. And so this is called the Mars 2020 mission, which has been renamed the Perseverance rover. And this is modeled after, the spacecraft itself is modeled after Curiosity. This has very different experiments on board. This is more of a biochemist. It's able to look for evidence of organic molecules, fossils, just to actually look for evidence of past or present microbial life on the surface. And Perseverance actually has a core drill where it will be able to pull up samples out of rocks and tuck them into little sample canisters. It's got something like 43 of these sample canisters. And the whole idea is they will very carefully select the samples that go into these sample containers, and then periodically they will drop off some of them on the surface. And the idea is later in the 2020s, there will be a Mars sample return mission, which will land a little fetch rover, they're calling it, somewhere near where Perseverance is. It will drive around and collect these sample canisters, tuck them into a small rocket on board the landed spacecraft that will launch back into Mars orbit, carrying those samples. A separate orbiter at Mars will then rendezvous with that sample capsule, pick it up, and launch itself back to the Earth. And so by early in the 2030s, if that stays true to schedule, we will have some very carefully selected samples from the surface of Mars. So that's something to look forward to. One thing that's just sort of a neat feature of this mission is they've got a little helicopter drone that they're going to test out. And this is purely an engineering experiment, but they've designed this based on wind tunnel tests on the Earth and operating it under Mars conditions, that this should allow them, with a solar-powered drone, to do flights of roughly 1 minute. And it's got cameras on board, so they'll be able to just see what kind of observations they can do. And it's really a proof of concept. So this is called Ingenuity, the the nickname for this, this little spacecraft. And so about a month after Perseverance lands, this little helicopter will be lowered from the bottom of Perseverance, and then the rover will drive off 100 meters or so, and then they'll be able to spend about a month testing out the helicopter. And so this is just the preparing for launch. There's the rover tucked up into its entry capsule. Here's the heat shield. This is the whole spacecraft being all tucked up and ready to go into its the nose cone or the payload fairing of the rocket. And here they are encapsulating the spacecraft. Once that's done, they truck it out to the launch pad, put it on top of the Atlas V rocket, and get ready to send it to Mars. I should say there's this huge Denver connection to this mission. The rocket is built by the United Launch Alliance, which is headquartered here in Denver, and the heat shield and the entry capsule and the deployment mechanism for the helicopter were all built by Lockheed Martin, also here in Denver. So here's the rocket driving out to the launch pad, and on the 30th of July, Perseverance and Ingenuity got their push to Mars in a very successful launch. So I think that's where I need to stop. I'll leave this up if we can, and these are our websites, or if you can do a screen grab of this. All of the NASA's Mars missions are available from this website. There's very frequent updates, things like Curiosity. Every day that the new images are received on Earth, they're posted on this website. So that gives you the opportunity to look over the rover's shoulder. This NASA.gov website is the NASA TV network, and so you can log into that to get updates and live launch coverage, things like that. And then here's a commercial website, spaceflightnow.com, that does really excellent coverage of launches and various milestones as they happen, and that's sort of my go-to place that I check every day when I first start the day to see what new is available in the space realm. And so I think I'd better stop there. And I'll stop my screen sharing here. And I guess if we have any questions, I can try to answer them.
But you answered the question earlier, and that was absolutely fascinating. Do they have any plans of dealing with Curiosity's tire problem? Is there a local Big O that they could go to, maybe?
Well, that's sort of the conundrum here. Is no, there's no way to repair those wheels. All they can do is try to use them gently and not, you know, it's slowed them down somewhat because they have to do all this reconnaissance of the road ahead. And in some cases, they actually have to back up to get to a safer path. And so that's the operational constraint that they're working under. But what they did do is they redesigned those wheels on the Perseverance rover. So they're much—
I was going to ask, yes.
Yeah, they're much more robust wheels, and they do not expect to have any problems whatsoever with the new design.
Well, brilliant. Well, that was absolutely fascinating, and I'm posting the links into the stream chat on Twitch.
Okay,
and
thank you.
The recording will be made available on the YouTube channel. And there was someone who asked about your thoughts on the movie The Martian, and I told them that they can watch all of your amazing comments on the panel that you did yesterday, which was all about the science in science fiction.
Yes.
So thank you so much for this, Dr. Steve. And do you have nice plans for your retirement?
Oh, working in my garden, and I'll still be doing Mars research about 1 day a week at the Space Science Institute up in Boulder. So that'll be ongoing, but I think my big goal is to avoid as many meetings as I can possibly avoid and just sort of have a more relaxed existence.
That's an excellent goal, sir. Well, thank you so much. This was absolutely fascinating. And we'll be booking our socially distanced holidays there in the near future, I hope.
Yes, well, and hopefully we'll have lots of great results to share this time next year, because these new missions will be there by then.
Well, we will definitely look forward to hearing about that. Thank you so much. Okay. Have a great day.
You too. Thanks, everybody. Bye. Bye.